Hello viewers, today we are going to see about Photo Diode NCERT syllabus, page number 487. So this topic we are going to see. A photodiode is again a special purpose PN junction diode fabricated with a transparent window to allow light to fall on the diode. So basically it is a diode. This is P-type material, this is N-type material. If you see the photodiode, there will be a lens, okay, two leads. The lens is made in such a way that the focal point tries to focus exactly on the junction of P and N-type material, this point. So light is allowed to fall through this transparent window. It is operated under reverse bias condition. So this is P-type material, this is N-type material. P-type is connected to negative and N-type is connected to positive. Therefore, the diode is, PN junction diode is, or photodiode is reverse biased. When the photodiode is illuminated with light, photons with the energy h nu greater than the energy gap Eg of the semiconductor, then electron hole pairs are generated due to the absorption of photons. That is, when the light falls on this junction, so light is nothing but photons, the energy is given by h nu. When it overcomes the energy gap in the PN junction diode, then it forms electron hole pair. The diode is fabricated such that the generation of electron hole pairs takes place in or near the depletion region of the diode. So the diode is fabricated in such a way that the electron hole pair appears only near the junction. That is, this side is electron, this side is hole, they will try to combine with each other. So it becomes electron hole pair. Due to electric field of the junction, electrons and holes are separated before they recombine. That means the electrons move away from the junction, the holes move away from the junction initially before they recombine. But once the energy of the photon overcomes the band gap energy, these holes and electron will try to recombine. The direction of the electric field is such that the electron reach N side and holes reach P side. So electrons will move this side and holes will move this side. Okay. Electrons are collected on N side and holes are collected on P side, giving rise to an EMF. EMF means voltage. So the potential difference between these 2 points at the ends of the photodiode will give results in a EMF. EMF means a voltage is developed. When an external load is connected, current flows. So this is as far as when the voltage everything is not connected, but when you connect a load RL, current starts flowing. So the conventional current will go like this and electron flow will be in the opposite direction. The magnitude of the photocurrent depends on the intensity of incident light. So the intensity of the incoming light, if increases, the reverse current also increases. Just if you see this graph, this is reverse bias. So here it is a reverse current. This is a intensity 1, intensity 2, intensity 3, intensity 4. Intensity 4 is greater than intensity of light I3. I3 is greater than I2. I2 is greater than I1. That means When the incident intensity of the light increases, reverse current also increases. So this is in third quadrant, the reverse voltage and the reverse current. It is in microamps. It is easier to observe a change in the current with change in the light intensity if a reverse bias is applied. Thus, photodiode can be used as a photodetector to detect optical signals. So one advantage of using photodiode is you can detect optical signals. The circuit diagram for the measurement of IV characteristics of photodiode is shown in this is the circuit setup. So we will see the practical way of doing how to use the photodiode. So basically you can have a LED. So this is LED. It starts emitting light, and the other end you will be having a photodiode. Okay, this will start receiving the light. So as I told you, the photodiode is reverse bias, that is p-type material is connected to negative. So here we have n-type, this is connected to positive, and the p-type material is connected to negative. Now the LED light falls on the photodiode, therefore reverse current starts flowing, and if you want to measure the voltage, you can have a load resistance RL at the other end, or if you want to detect the current, you can have a microamps meter so that you can detect. So what happens is, initially you are measuring the potential difference between these 2 points. So this is positive and this is negative. So what happens is, as it is without any disturbance, this is LED and this is the symbol for photodiode. Now the LED lights emits light and it is received by the photodiode. Normally assume some current flowing in the circuit. So what happens is, assume because of the current, the voltage drop across this resistance is say 10 microvolt. This is normal case. Suppose an intruder or there is an obstacle, suddenly a person, so a person walks in and moves. So there is a block in the intensity of light. The person blocks the light. Therefore, the light that is usually received by the photodiode, now it is being blocked. So there won't be any charge carriers. Therefore, from 10 microvolts it may lead to 1 microvolts. You assume like this because of this block by an intruder. So that means if 1 microvolts if I sense here, that means somebody has crossed that line. You can use for counting also. For example, in temples and all, or in the railway station, how many persons are entering or leaving. For that we can count number of persons. So first person, first you will get 1 microvolt, then once again it will maintain 10 microvolts. Then when the next person goes through this setup, once again it will be 1 microvolts. Likewise you can count. You can attach a digital counter and we can count. This is one of the applications of using an LED and a photodiode in combination. So the main idea of a photodiode is, you have a lens setup. The focal length of the lens is exactly focusing on the PN junction diode. So light is allowed to strike through this lens. So it strikes the PN junction. So because of that, initially the electrons moves towards this and the holes moves towards in this direction. Afterwards, the electron and holes will try to recombine. Because of that, current flows into the reverse bias current. reverse current flows into the circuit. If you attach a load, you can sense that current. So the photodiode operates only in the reverse bias region. Even though you can operate in forward bias, it is meant only to operate in reverse bias region. And this is one application I have told you. You can use photodiode for many type of applications. Hope you have understood this topic on photodiode. Thanks for watching. Nandri.